Hello, this is what is the length of a curve part 2. In the last video, I showed you a strange example. Let's review it. This is Euclidean distance. The straight path is shorter than the detour path. This is Manhattan distance. So this zigzag path has the same length to AB, BC. But these are like contradiction, because if the grid size is smaller, then this yellow path looks like a straight line, and here straight line is shorter, but here are the same. So they look contradiction. That's odd. Going straight and detour are the same length. At that point, I was confused. Do I really know what the distance or length is? That was a moment I noticed something wrong. But I also found this is a great opportunity to learn. So I realized something was wrong, but what exactly is it? So where does something wrong come from? In Manhattan distance, when the map is grid, no matter how many times I turn, the lengths are the same. I think this could be the source of my problem. Okay, let me show you another animation. We are moving A to C. If you move the midpoint, you see the path changes and also path length changes. Let's think about this path as an example. So first, I only think about AB, and I cut and move and cut and move, so the length AB didn't change. It just distributed to the path. Same as BC, I cut and move, so the BC length didn't change. But here is the odd part. As I keep doing this, the line AB, BC looks like converged to this path. The same story as this path. You just cut and move. By now, you see the pattern. This works for any passes. The orange detour path and all yellow passes have the same length, but that's impossible. This is the reason I feel odd. I should have misunderstood something. Actually, it's hard for me to accept I'm wrong. But realizing a mistake also means I might be one step closer to the truth. That's kind of exciting. I think mistakes are gifts. Next, let's think about the curve. If I can turn as many as possible, then I can approximate any curve. Of course, if you go backward, then it became longer, but that's not the case I'm talking about. So let's try on a circle and a part of a circle. Here, I want to make a program to visualize approximation. Why do I want to make a program? Because for me, making is an understanding method. By working with my hand to create something, if it works as I expected, then I feel I get a deeper understanding. But if it doesn't work, I think I didn't understand well. Although if I just want to see the visualization, I can ask the AI to make it, but in this time, I want to understand well, so I will make it by myself. I learned that making a way of understanding at my university. In a computer science class, professor asked us, "Do you understand addition?" So we answered, "Yes, of course, I know 1 plus 1 is equal to 2. And then the professor said to us, "Okay, if you understand addition, can you design a machine that performs addition?" At that moment, I realized that I did not deeply understand addition. From that day, I asked myself, do I just memorize it? Or do I really understand? There are so many different ways of understanding. One way to check is to ask myself, can I make it? Can I write a proof? Can I explain it to others? Making something is a good way to understand, but it is actually not enough, because It is still possible to make a lot of things without understanding. It is a good tool, but it doesn't guarantee the end. So I am still asking myself again and again, do I understand it? This is one of such my journey to understand. So for implementation, I love using 3 blue 1 brown's Manim to visualize these concepts. Manim is an animation creation tool. For example, I made some animations using Manim. It's fun to create, but it is also time consuming for me. So today, I'll use Google Colab instead. I hope it simplifies a bit. Okay, let's plan how to implement it. My goal here is approximate a circle using Manhattan distance. So first step, I would like to draw a square and a circle. For simplicity, I only think about the first quadrant. So this is a square, this is a quarter of circle. And step 2, I want to fold the square once. What does it mean? To fold the square, this corner, I want to make a small square here. To do that, I draw the y equal x line. And then there is an intersection point. From here, I have a vertical line and horizontal line. So this is a square, so these all edges are the same length. Then this length come to here, this length come to here. Therefore, this length and this length are the same. But the shape is a little bit closer to the circle. Then step 3 is repeat this folding again and again. To do that, from this intersection point, I have 45-degree lines. And then there's an intersection point to the circle. Then I have the same operation again. You see, this is the original square, and then there is a first approximation, and this is the second approximation. The shape is much closer to the circle, but the length didn't change. This is the basic plan. Let's implement it in Colab. So here is a library. I would like to use matplotlib. So step 1 is about the square and the circle. The first I need a circle equation of radius 1. This is the Pythagoras theorem, but for simplicity, I want to draw in the first quadrant only. Okay, let's implement this one. The unit length is equal to 1. And what is the spatial resolution? The next is circle function. So I will make an array of the points. Circle x. Let's see what kind of points are generated. Oh, there is a typo here. If you see is x equals 0, then y equals 1. And if x is increasing and y equals a little bit decreasing, that would be the circle from the quarter circle. Now I would like to draw square 2. So I'll put in the 3 coordinates. I set S0 is the first level, level 0, and then we subdivide later the level 1, 2, but first one is 0. And what's the point? The x equals 0 and y is 1. 0, 1, 1, 1, 1, 0. Now I would like to draw a figure. I have a document of matplotlib here. So I use this example to draw a figure. Okay, let's try out. Let's debug it. Yes. The red line is a quarter circle. There are 200 points. We saw them in arrays. And the blue one here is 1, 0, 1, 1, 1, 1, 0. Now step 1 is done, but before go to step 2, I found a mistake in the equation. This is correct formula, and in the code was correct. In the last video, I used rectangle in the proof, but here I will use squares. Because the edge length of a square is the same, so it's easier to see I didn't change the length. Then let's make a plan. So I want to make a square here and fold once. How can I fold this square? First, I draw a diagonal line. This point I call P0. The intersection point I call P1. From P1, I draw a horizontal line and a vertical line. At this point, I call P1R. This point, I call P1L. From P1, this is right, this is left. Because this is square, so these lengths are all the same. Then I fold this one to here and this one to here. This is a result of one folding. Let's name all the coordinates. I said P0's coordinate is x0, y0. And P1, I said x1, y1. P1R's x is the same to here, and y is same to here. The P1L, x is the same to this one, and y is same to P0. We know the P0 is 1, 1, so if we know P1, then we know everything. And we have all formulas. Later, I need to move this line up and down, so I put alpha, and the circle equation is x squared plus y squared is equal to 1. So we can solve this equation to find P1. Then let's solve it. You can ask the AI to solve them, but for fun, I will do by my hand. So I will put the result. I will write it down. So here's the solution. But for P1, alpha is equal to 0. Therefore, P1 is square root 2 over 2, comma, square root 2 over 2. Let's implement this. We have P0, coordinate is 1, 1. I want to have an intersection point, P1. Alpha is y minus x. And x is this. And y is equal to x plus alpha. Oh, that is there. So intersection point is there, but I want to have P1L, P1, P1R. So generate 3 points. From L to R, generated points are 1, 0, 1, 1, 0, 1. 1, 0, 1, 1, 0, 1. Am I right? 1, 0, 1, 1, 0, 1. 1, 0, 1, 1, 0, 1. Okay, generate the points. Now we have all the coordinates. Interesting suggestion, but not right. So level 1 approximation start with 0, 1 and P1L, P1, P1R and end at 1, 0. So starting at 0, 1, generated points 1, 0. And let's draw the first approximation too. Okay. Float object is not callable. Missing comma. Ah. What? I think intersection point is correct. Yeah, square root 2 over 2. Yes, this is first approximation. So I folded the square here. Okay, let's go to step 3. Folding the square multiple times. Let's plan it first. This is first approximation. The second approximation starts with P1L and P1R. For the second approximation, we do basically the same. From P1L, there's a diagonal line and making a small square and horizontal line and vertical line. And here, intersection point P21, there's a R and L. From P1R, draw a diagonal line and intersection point I call P22, and there is a L and R. And this is the second approximation. Let's back to the first approximation. At the first approximation, we start with P0 and intersection point P1 and then make L and R. The second approximation, basically the same happening. If you see here, from P1L, there's a diagonal line, then intersection point P21, from P21, horizontal line and vertical line, and that is L and R. Here is also the same. For one step, from the corner point, intersection point and L and R points are created. For the program, for the corner point, 3 points are generated. Corner point, 3 points are generated. Corner point, 3 points are generated. This is the pattern. To do this in computer science or mathematics, it is called recursion. So basically the same pattern but different data. However, you might notice this is not the same topology. In the creation process, from the corner point and intersection point connected to L and R. But here, from the corner point, intersection point, L and R is not connected to here. These are different topology. This is the geometrical representation from the corner point and intersection point and L and R. But in the program, from P0, and these 3 points are generated. This is the data structure I want to store in the computer. In the computer science, this is called tree structure, and this is 3 nodes, so it's called ternary tree. And here is a level 1 approximation, here's level 2 approximation, and we go level 3, 4, 5. This is the plan. Then let's implement it. But this time it will take long, so I will cut to the result. Okay, here's the implementation. This is level 0 approximation, so nothing there, and level 1, 2, 3, 4, 5. Every time I only fold the square, therefore the length is not changed, and I can calculate what is the length of the blue line. However, you see, the blue line became closer and closer to the circle. In this program, I didn't change the length of the square, so the folding the square multiple times that resulting to the pi is equal to 4. But what was wrong? But this video became a bit long, so I will explain what was wrong in the next video. Part 2 video summary. I implemented a program recursively subdividing line segments to approximate a curve. And then, the curve length is equal to line segment length. And is it really correct? That is the first question. And do I have any unconscious assumptions? Because pi is not equal to 4. I hope I will conclude this video in the part 3. Thanks for watching.